Here is another example of how we use hypothesis testing. Medical Rehabilitation Education Foundation reports the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of that rehab is different at a particular hospital, a researcher selects a random sample of 35 stroke victims and finds the average cost of their rehab is $26,343. The standard deviation of the population is 3,251. At alpha equals 0.01, can it be concluded that the average stroke rehabilitation is different from the 24,672? All right. From that information, we now need to identify our null hypothesis. And our null hypothesis says that the cost of the stroke rehab is $24,672. And then the researcher wants to know if that is different at this particular hospital. So it's not saying is it greater than or less than, but it's not the same. So we're going to use that greater than or equal to not in this case, but rather the does not equal to. With that being said, then, we're looking at a two-tailed test. Okay? A two-tailed test would then cause you to look at that critical value just a little bit different. Okay? Now, the alpha that the researcher was trying to use is 0.01. Because it's a two-tailed test, we're going to take our alpha and divide by 2 because both pieces need to be shared. Okay, that's going to give us 0.005. Now, that 0.005 is where we would go to our table and look for that 0.005. 0.005. I'm looking at my table. Okay, here it is. A little bit farther down. Negative 2.5. It's closer probably to this 8. So we'll use the 8 one. Go back to my document so I can write that down. So that's our Z. Our critical value will be 2.58. Now that was a negative, so that ends up being our left boundary. So negative 2.58 goes here. Because it's symmetrical, we're going to say our positive or our upper boundary will then be 2.58. Okay, there's our beautiful picture with the two tails shaded in. Now step 3 says we need to find our test value. Because we're working with the situation where we know our standard deviation of our population, we can use our Z value, the value we're trying to test, and the mean that was given of our sample. In this case, the mean was 26343. And then the actual mean of the population is 24672. Divide that by the standard deviation of the population, 3,251. Divide that by the square root of how many are in our sample. Okay, get that calculated out, and it ends up being 3.04. Okay, so this is our test value. Our critical areas is less than negative 2.58 or greater than positive 2.58. Okay, now because our value is 3.04, that falls in this region here. It falls in our shaded or our critical region. Because it falls in our critical region, we can now say that we can reject the null because it fell in that critical region. Therefore, the summary states that there is enough evidence to support the claim. There is enough evidence because it fell in our values. Okay, now that was what we call the traditional testing. Here we're going to go into a p-value. This is another option for testing whether your hypothesis is true or not. A p-value is the probability of getting a sample statistic or a more extreme sample statistic in the direction of the alternative hypothesis when the null hypothesis is true. So it's that probability again. Decision rule when using p-value. If the p-value is less than or equal to alpha, we're going to reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. Here are the steps for finding the p-value. They're very, very similar to the z-test method. However, here they're looking at, when you're looking at this one, we're going to compute the test value, then we find our p-value. Okay? Make a decision, summarize the results. All right. The cost of college tuition example. A researcher wishes to test the claim that the average cost of tuition at a 4-year public college is greater than $5,700. She selects a random sample of 36 4-year public colleges and finds the mean to be 5,950. The population standard deviation is 659. Is there evidence to support the claim at alpha equals 0.05? Use the p-value method. All right, with that being said, let's go ahead and talk about how we state the hypothesis and identify the claim. The researcher says we want this, it's greater, wants to be greater than this. Sometimes I find it easier to find the claim and then do the null hypothesis from there. Since my null hypothesis cannot be a greater than, less than, equal to, I know that my alternative hypothesis would have to be the greater than. And this was the claim of the researcher. That makes my null hypothesis the equal to the 5,700. Remember, we don't want to change the null hypothesis. Okay. Step 2 is then to compute the test value. In this case, the test value is going to be a z because we do know the standard deviation of the population. Our mean of the sample that was given to us is 5,950. The mean of the population, 5,700, divided by the standard deviation, 659, divided by the square root of our sample size. Again, looking at 36. Okay? Type that into your calculator, push enter, and we get 2.28. Okay. That's our test value. We're going to test it and compare it to our p-value. Okay? So our p-value is, using our table E, we want to find the area for z equals 2.28. So z equals 2.28. Go to table E, and we're going to look for that area for E. Okay, so 2.28. 2.228. I see 0.9887. .9887. This becomes our p-value because this value is to the left of our value. We are looking at a greater than, which is our right-tailed test. We want to take 1 minus this to get 0.0113. Remember, the z-test, this is what we just did, but we want to know the greater than, so that's this piece here. We take our value we found from our table and minus 1 from it. Here is our p-value. Now that you have identified the p-value, we want to compare it to our alpha, okay? Now our alpha was 0.05. How does our p-value compare to our alpha value? We'll notice that it is less than our alpha value. Because it's less than our alpha value, when it's less than, we reject the null hypothesis. So here is where we're at. Since it's less than, the decision is to reject the null. Okay? And then we can say for our summary that there is enough evidence to support the claim that the tuition and fees are greater than $5,700.